Hello everyone, welcome to another video. So this is going to be a walkthrough of some of the more difficult questions selected by you for the paper 2. Okay, so we are going for question 3 first. So let's start. So we need to determine the ratio of the volume of these three shapes. So these are all standard shapes: sphere, cylinder, cone. And then we've got to reduce it to simplest form. So ratio, right? So you notice there's no numbers given, so we need to just whack in the unknown. So r is the only unknown here. So for volume of the sphere, you can see that it's just 4 over 3 pi r cube, no problem. So I think the volume of the cylinder gives a bit of problem because it is supposed to be pi r square times height. So like, why is the height 2r? I think most people will not have realize this. So let me draw this out for you. You can actually see that if this is a sphere, this is r, this is r. That's why for the cylinder, it is actually 2r. And similarly for the cone, it is also 2r as the height. So this dotted line here, you can see this dotted line here is written for a reason. It's to tell you that the height of these two shapes is 2r. And once you realize that, you can easily put all the formula in, and you notice that pi, 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 and the r cube, r cube, r cube all can cancel, and you're left with this ratio. And of course, you cannot leave ratio as a fraction, right? So you need to everything times 3, and then you get this eventually. Okay, so next part. Given that the cylinder is a solid cylinder, again, why do I highlight solid cylinder? Because the word solid matters. Once you say the word solid, that means the top part is not empty, which means you must count this as part of the surface area. So the surface area will be the top circle, the bottom circle, and the curved surface area. And that's why you get pi r square times 2. This is the top and bottom. And then here you get 2 pi r, which is the diameter times the height, which gives you the curved surface area. And then you add together, blah blah blah, you get this. After that, because they want the percentage, right? So you're taking the this one over this one. So this is the surface area of the cylinder, and the one below is the surface area of the sphere. And then you do your normal maths, you get 150%. Okay, so now for part 3, you notice that they ask you when the water level is at half the height of the cone, determine the fraction of this half and then the entire cone. So if you look at the cone over here, let me change a different color. So we want at half of the cone, right? So this height over here will be r. Oh, sorry, yeah, half, because it's half only, right? So it's r. But the problem is we do not know the radius when it's at this red color level. So we can't really find the volume and then divide normally. So we're a bit stuck here. So what we need to do is we need to do the similar triangle trick, because this red cone over here, this whole part, it is definitely similar to the entire cone. And since we want the fraction of the volume, we can actually take the fraction of the length. So the height is r versus 2r. That's why the ratio is 1 over 2. And that's the length, right? So you need to change from the length to the volume. You need to cube both numbers. So actually 1 cube is still 1, but 2 cube is 8. That's why the so-called the fraction is 1 over 8. This is the only way to do it, because we do not know the value of this r at this level of the water. Okay, so that's the way we do it this way. So next, let me scroll the question down. Okay, so let h be the height, and then we need to what? Copy the axis and sketch on the graph to show the height where the water level changes as the water is poured in. So let's go back to this cone over here. You can see that initially the water level will rise very fast because this is a very small area. So it will go up very fast. But as I keep going, the the height will be increasing slower and slower, because the so-called radius of the circle is getting bigger. So it takes more water to fill up 1 cm. So you know that this is getting slower and slower, and this is actually a decelerating curve. Okay, so you can see that if I from the answer you can see that the height is always increasing because the water keeps going in, but it is increasing slower and slower. See, it's always increasing, but it's increasing at a slower rate. This is what we call a decelerating curve. Okay, so if you do not know this, it's going to be very difficult for you to do this type of question. Okay, so next question. So the next question we're going to do is question 4. So this is a huge table. I'm like, what on earth is this when I first look at it too? So I went straight for the question. Okay, so using the patterns in the table, express A in terms of K. So where is A? A is over here. K is over here. So between left and right, you notice that it's just plus 1, plus 1, plus 1. After that is, in fact, from here you plus 1, plus 1. In fact, the whole thing is just plus 1, right? So in A in terms of K, so this in terms of K, that means it's K plus 1 equal to A. So that's why A is K plus 1. So where's B? So B here, B. Again, in terms of K, right? So starting from K is plus 1, plus 2, plus 3, plus 4. That's why B is K plus 4. And similarly, C is beside, that's why C is K plus 5. So done. This is the easiest 3 marks in the world. Okay, so let's continue. I want to simplify AB minus KC. So literally from here, I'm going to sub in A, B, and C. So A, B, and C. I sub it in. I go and expand everything, simplify. Everything happens to cancel, and I'm left with 4. Okay, so that's done. So now this is the difficult part. Explain why AB and KC always lie in the same column. So the first thing we need to figure out is, what does same column mean? So you see, the keyword is actually here, same column. Okay, so same column. So let's go up here. If I look at the same column, what is the linkage between the numbers? You see, from 2 to get 6 I plus 4, plus 4, plus 4. Similarly, for this column is also plus 4. In fact, every column, the numbers will plus 4. Okay, so if it's in the same column, it is likely that it's going to be multiples of 4. So let's go and see. So if I take AB, KC, you see it's AB minus KC, the answer is 4. That means this number minus this number, the answer is 4. If the answer is 4, clearly they are going to be in the same column because all the numbers in the same column are differing by 4. So that's how they explain in this part over here. Oh, can't see. Let me scroll this a bit. Yeah, so that's why the answer is this part. Okay, so then let's continue. So let's go for C. So the number K is in the row N of column 1. And then I need to find the expression in terms of N for K. Okay, so what they want you to do is, let's say this number. I need a formula that gives me this 2 and the variable is 1. So this is the so-called N here. And this number is the K. So I need some sort of formula. Okay, some formula. When I sub in N, I'm going to get 2. In fact, to be even more to be clearer, in order to get 2, I need to sub 1. Okay, and in order to get 6, I need to sub 2. So if I sub 2, my K should be 6. So this is your basic algebra. You need to create some sort of nth term. And in this case, how I do it is, it's always going to be some number times your n, and then it's either plus or minus some number, and you will get your answer. So let's use the first column as the answer. So I want 2. My n is 1. So I'm going to change n to 1. Let me erase like that. Okay, and usually this number comes from the so-called pattern here. So you can see that from 2 to 6, 6 to 10 is 4. So let's try 4. So I'm at 4 times 1, I get 4. In order to get 2, I need to minus 2, right? So I need to minus 2. So my suspicion is 4n minus 2. So what I do is I'm going to try. If I sub 2 into n here, so I'm getting 4 times 2, 8 minus 2, 6. Oh, correct. So let me try sub 3. If I sub 3 over here is 12 minus 2 is equal to 10. Once I try a few, I'm very sure this is correct. And that's how you get this k equal to 4n minus 2. Okay, so let's continue. We're at part D now. This is probably the most difficult part. So determine which row and column the number 375 belongs to. And again, you must know that some stuff on top must be useful. And most likely in this case, it's going to be the 4n minus 2 here. So what does 4n minus 2 gives you? It gives you the row. Okay, so it tells you like which row. So is it row 5, row 6, row 7, or row 100? Okay, so if I sub, or rather if I equate this 357, so is it over here, 357 equal to 4n minus 2. As a source, I get n equal to 94.25. The first question is, how on earth can you ever get a decimal? It's supposed to give you a row, right? So imagine this is row 94. Okay, if it is 94 exactly, it tells you that your 375 is here. But unfortunately, the answer is 0.25, which means your 375 is either here, here, or here. So how do we know where? So the smart way is actually, if I sub 94 back into here, you see what they do is, see, I sub 94 into this formula, 4n minus 2, I get 347, which means 374 is here. And by the law of common sense, if I want 375, then 375 is obviously here, right? Because it's plus 1 plus 1 plus 1, and that's why the answer is column 2. Okay, so the next question will be question 6. I know this is vectors, and we all hope that with the school closure, this topic is not going to be included in the exams or whatever. We still got to go through, right? Okay, so the diagram shows a parallelogram. So in vectors, it's very important that as you read the question, you need to top up. So the moment I read parallelogram, so this whole shape is a parallelogram, it implies many things. Because first of all, it tells me that this is also A. Why? Because if OR is A, then PQ is also A, because parallelogram, so these two are parallel. So in the same theory for here and here. So this is also B. Okay, so let's continue. M is the midpoint of OQ. So M is here, OQ is here. So that means midpoint means this and this is the same. Next thing, K is the midpoint of OM. So K, where's K? K is here, midpoint of OM. So same thing. Again, is this and this are also the same length. So you notice that there's so many same length. I might as well just delete everything. In this case, I will write 1, 1, and this is 2. So when it's all in terms of ratio, you can see it easier. Okay, so next, continue. I'm here. So OL equal to 2LR. So I realized that it's pretty difficult to read like this. So what I usually do is I divide the LR over. Okay, so all the so-called letters on one side. So once I get here, I divide, it becomes OL over LR, and then on the right side becomes 2 over 1. And then from here is very easy because OL is 2 parts. So OL is 2 parts. So let's write 2. And then LR is 1 part. So LR is here. So this is 1. So as you read the question, if you write all these numbers down, it will help you immensely in your whole question. Okay, so let's start with the first part, OM. So where's OM? OM is here. Okay, so this is a typical triangle rule. In fact, the whole vectors is about triangle rule. So OM is actually, you realize, is half of OQ, right? So if I can find OQ, I just need to halve it. So what is OQ? So if I start from O, I end at Q. What I do is I come here and I come here. That's why this is B plus A. So you can see that your OM is just half of b plus a. They write a plus b because usually you want to write a first, so that's fine. So that's OM. Next thing, PK. So PK is where? PK is here. So let's write the arrow here because I want to go from P to K. So from here to here. So same thing. I need to start at P. I need to end at K. So to start here, I can come here, this direction. Okay, so this direction, which means this direction is negative of here. So it's negative B. So here, negative B. And then once I'm here, I need to plus here. So I need to go this direction. And so this direction is actually half of OM. So you can see that OM is this one, right? That's why you can see OM is here and then half of OM. After you get this line, actually you are done already. You just simplify, blah, 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 you get this. Okay, so next part, ML. So ML, same thing. I want here M to L. So I need to start at M, I need to end at L. So starting from here, I can come this direction. So that will be MO. You realize I have OM, so it's just the negative of this. So you can see that here, yeah. So it's the negative of this, so here. And then once I'm here, I can travel here to reach my destination. So this is where this 2 and 1 comes into play. So from O to R is 3 parts, right? So 2 plus 1, 3 parts. But I only want to travel 2 parts. That's why this is actually 2 over 3 of the whole thing, which is A. That's why this part here, see? Is 2 over 3 of A. So once I get this, I simplify, blah, 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 I get 1 over 6 of this. Okay, so now that we are done, we'll go for the B. So PK and ML are parallel. We need to explain why. So as with all vectors question, they will always help you along the way. So you realize PK, see, I have PK already. ML, I have ML. So let's look at what's PK. PK is 1/4 A minus 3B. ML is over here, 1/6 A minus 3B. So the most important thing you must realize that here and here is the same vector, and which is why if you look at the explanation, they say I like this explanation because it's very neat and cool. So these two are scalar multiples of vector a minus 3b. This is this vector. So this is a certain vector. If I times 1/6, I get this. If I the same vector, if I times 1/4, I get this. So it means that these two, this pk and a minus 3b is parallel. ML is parallel to A minus 3B also. And since, and of course, with that, these two, this and this are also parallel. So I like this explanation because it is short and sweet. And I do not need to go and find the number like they do on top. So very troublesome. So this, I feel that is something you should learn. So this part is something that you should learn because this is a very neat and fast way to explain. Okay, so next thing. I need to show that the two triangles are similar. So what two triangle? OML, QKP. Let me highlight the triangle first. Okay, so I'm back after pausing the video. Notice that I've already highlighted many things. So this triangle is actually the blue color one, and then this triangle is the green color one. And then you know that when they are proving similar, the letters must match, meaning O and Q must match, which is why you see I draw this purple color box. O and Q actually match. But the problem is if you draw it on the diagram, it's very hard to see because you need to rotate, reflect, and whatever crap. You can't really see the triangle very well. So what I do is I draw at the side. You see, I don't really care what the shape is. I just want to draw two triangles, similar in, similar enough. But the important thing is O and Q must match. So O and Q are the one on top, then followed by M and K. So M and K is on the left side, and then finally L and P are on the right side. So the actual shape doesn't matter. I start from here. So I need to look for things where certain angles or certain sides have certain ratios. So I start looking. So the first thing I try is, are there any angles that I know? and you see that there's some parallel thing. So if you know there's parallel, there's going to be some alternate angle somewhere. Okay, so these are the two parallel lines, and you can see that this and this alternate angle. So here, here, alternate angle. So let me check. So the angle at K is over here, and for this blue triangle, the angle at M, and you see that exactly it fits the same corner. So I'm getting somewhere already. So once I have this angle, if I can show that these two sides have the same ratio, I'm done. So I look at OM and KQ. So OM is where? Where's OM? OM is here, and KQ. Okay, so OM is 2 parts, KQ is 2 plus 1. So OM is 2, KQ is 3. I got some ratio here. The next one I'm going to check is if I can show that this and this got some ratio and it's the same ratio, I'm done. So I look at ML, ML is where? ML is here, versus KP. KP is where? KP is KP. So do I have the ratio of this one and this one? Okay, looks like I don't have, so no choice. Let's try for another angle. So let's try these two. So based on this is MOL. So MOL, so it's this one, and then this one is KQP. So KQP is KQP. So it's here. So is this and this the same? It is, because this whole thing is a parallelogram, so it's a Z thing, so it's an alternate angle. So that's why, see, in the solution, this and this is actually this and this, they are the same alternate angle, and then these two are also alternate angle because of these two parallel lines. So alternate, alternate. Once you get two angles, the last angle over here is automatically the same, because the law of common sense tells you that uh, just 180 minus these two. So these three angles and these three angles are all the same, and therefore the reasoning is similar three pairs of corresponding angle are equal. So in fact you can just write, and I prefer this, so this is what you should be writing using the AA similarity test. You can call it AAA also, up to you, and these two triangles are similar. Okay, so for the next part, okay, so we're at the part where we ask for area of some triangle over some triangle. So this is pretty standard question, and you know that there's only two ways that you can do such questions. One is usually using similar triangles, and you already have some similar triangle. There's a good chance that this is that, or you can use the common height trick. Okay, so let's look at the triangles we're looking at. So QKP, same lah, QKP, OML, OML. So actually it's these two triangles, and I want the area of the ratio of the area, right? So what you do is I take the length first. So which triangle first? This one first, right? So it's 3 over 2. Okay, it's 3 over 2. You can see my mouse over here. But this is the, remember, 3 over 2 is the length. To change the ratio of the length to area, I need to square and square. That's why the answer is 9 over 4. Okay, in fact, there's no need for working. Just write this down. You're done. But the 3 square and the 2 square you need to show specifically. Okay, so next, which two triangles we're looking at? So it's still QKP, so still this triangle, but the other triangle is OPK. So where is OPK? Let's go up a bit. OPK. So we're looking at this triangle and this triangle. Let me color it. Okay, so I've removed all the useless things and highlight the two triangles we're looking at. So it's the blue and the green one. Okay, so and just by this, you know that this is definitely the similar height trick. So how to see this similar height? Once you realize that the two triangles have the same base, which in this case, this is the same base, isn't it? See, both triangles have this base. So where is this height? If you look at just the green triangle, if I from here I drop a perpendicular line down, this is the height, right? Let's call it h. And similarly, for the blue triangle, if I drop from the highest point down to the perpendicular, the height is the same height, which is why this is what I call the similar height trick. So look at the answer key over here. I want OPK first. OPK is one. It's the blue one. Okay, so OPK. So if I look at the area of this triangle, is half base times height. So the base is 1. So that's why it's 1 half times 1 times height. Let me write down this on the side. It's actually half times 1 times height. Okay. So let's do the one below. This QPK. QPK is this one, right? So QPK is the green color one, and the base is how long? From here to here. So actually it's 1 part plus 2 parts, so it's 3. So it's actually half base. This is 3 times height. Okay, and that is why this is called the similar height trick, because you realize that the height ends up getting cancelled away, the half also cancel away, and that is why it's 1 over 3. Now be careful, this is 1 over 3 is the final answer. You do not need to square, because this is already the area divided by the area, so it's 1 over 3. Okay, so finally we're at the last part. Okay, so given this triangle QKP as area 45, determine the area of the whole parallelogram. So QKP, where is QKP? Let's go back here. QKP, okay, so this is the green triangle. So this is 45 cm square. So we already know that the ratio between these two is 1 is to 3, right? So which means that this is 15. And since this whole thing is a parallelogram, obviously these two triangle and these two triangle are the same because it's parallelogram, right? So which means this whole thing should be 50, 60, and that's why the answer is just 60 plus 45 plus 15, which is actually equal to 120. Okay, thank you. So this is the question. Thank you. So the next question we're going through will be question 7a. Okay, so as with all these circle questions, you want to as you read, write draw on the diagram. So let's start reading. Center, center, A B C D E on the circumference. That means all these 5 points are on the circle. And then ST is a tangent, so ST is this one. So immediately when I read tangent, I know that this is a right angle, so I'm going to list it down right now. And after that, AD pass through O, so AD pass through the center, which indirectly tells you that this and this same length, and actually they are the radius of the circle. Okay, next. And then CE and AD intersect, so CE, AD intersect at here, so maybe I'll just put a dot here. I don't know what this is for yet. After that, angle 102, angle 46, angle 12. Okay, so I've listed down everything. So let's start. So list all the right angles in the diagram. So I obviously have one that's here. And then once I know that this is a diameter, actually this one is also a right angle. Then of course, since this is a straight line, then this is also a right angle. So there are 3 right angles here. DEA, DEA, this one. And then straight line is this one, and the last one is the tangent radius thing, this one. Okay, so next part. Okay, so next I have so many angles to find. So ACE, so ACE, E, so that will be this one. And once you see this, you are looking out for the chord. You can see that this chord over here, from here, this one, this, and this, they belong to the same chord. So this is 46. And the reason is angle in the same segment. Next, CEA. CEA. Isn't this the... this is not the diameter. Okay, so CDA. So let's see. I know. Because these are opposite angles in the cyclic chord. That's why this and this is equal to 180. So you see, 180 minus 102, we got 78. So this one is 78. Next, OFE. So OF, what's F? OFE. So this one. So let's see. Okay, I have a straight line here. So I think yeah, I can find this blue one because this is a triangle. So based on this two, I can get this, and then from here is 180 minus. So in other words, these two are the so-called exterior angles of this angle, which is why the answer is here, 46 plus 12. Okay, so next T, ETA. So it's ETA. Okay, so I'm going to use the big triangle. So this big triangle, because this is 46, this is 90, and hence the last one will be 180 minus everything. So see, 180 minus 90 minus 46. Okay, so the next part of the question is B, which is like totally no link, I think. Okay, so it shows paper cone, base area 22. So this base area is 22. Slant height, okay, slant height is 9. Open to form a sector, so like that. And then they want circumference of the base. So they want the circumference of this circle. So circumference is 2 pi r. So you realize the only unknown we need to find is actually r. And then the only information I have is this 22 and the 9, which means I need to form some equation to solve for r. So what is 22? 22 is the circle, right? See, the base of the circle, pi r squared is equal to 22. So equal to 22. So from here, I can solve for r. And in this case, r is 2.64 something. So that's the r. And then after that, I want to find the circumference, which is 2 pi r, which is why now 2 pi r, I'm going to sub r inside and blah, blah, blah. That's the answer. So the next part, you want to find angle AOB. So that will be AOB. So that's this one. And you must know that this is a certain portion of a circle. The whole circle is the 360 degrees. This is some angle. And this angle is linked to many things. So for example, this part over here I'm mousing over is the circumference of the full circle. And we already know that this is 22. Oh, sorry, not 22. This is 16.6 because this is the circumference. If you open up this, you get actually this. Okay, so a certain portion of the circle is 16.6, and then this slanted side over here is actually the radius. Okay, so based on this info, I can actually form an equation to solve for the angle here. So let's call the angle lambda. So this over 360 times the full circle, the full circumference, which is 2 pi, and the radius in this case is 9, and this whole thing is equal to 16.6. So you can see that there's only one variable here. I just need to make lambda the theta the subject, and I'm going to solve. Okay, they use the formula of arc length, which I don't personally like it. I like to use normal ratio so that I got one less thing to remember. Okay, for the last part, it says that if the radius OA, this one, of the sector remains constant, so that one cannot change, state what happens when to the height when an angle is increased. So if this gets bigger, what happens to this height? So this is the height that we're talking about, and this one cannot change. So you imagine what happens when this angle gets bigger. There's only one thing that happens. This whole thing gets bigger, which means this circle gets bigger. So let me draw it. If you imagine the circle gets way bigger, but this one is still 9. You have no choice but to, from here to here, it has to be shorter as compared to this, right? So the only way for this circle to get bigger without changing this is for the height to get shorter. So that's why the height will decrease. So that's all for the question. Thank you. So next we're going to talk about question 10. So this is the question. It says that given the strike length is used to describe distance covered in one step, calculate her strike length. So actually it's not very clear because are we talking about the walking one or the running one? So let's look at the answer first. So it says, oh, there's two answers. You use 2.44, this one. You can also use 11.01. So this is not very realistic because how can your strike length be the same when you're running or walking? So this must be one of those auntie who looks like they are jogging but they are as good as running. But never mind, I should not judge them. So let's continue. Let's use walking as an example. So kilometers, I need to think in cm. So the first thing I need to do is change the 2.44 into cm. So from kilometers to meters, you times 30 over here. Then from meter to cm, you add another 2. So that's why it's total 50. And then divide by the number of steps, then you get your answer. And then the 3SF. Now the next part of the question, we're supposed to determine the duration this person needs to run to burn off her McChicken meal. So this is the McChicken meal. Got three things: the burger, the fries, the Coke. And then again, you must take note is run. How much you must run. So it makes sense to find the total calories. So if I add these three together, you can see that over here, you add three together, but I think there's a typo here. It should be 213. Okay, so this is the total. Then the next thing we're going to go look for is actually if they're running, how many calories is this person burning per minute? So let's say because based on this 1 hour 2 minutes, that's 62 minutes. They burn off 603 calories. So if you want per minute, we need to take 603 divided by 62. So this is the amount of calories per minute. So then what we do is we take this divided by that. And the answer is actually over here. You can say the answer is 97.603. So how do we convert this minutes to hours? We just divide by 60. So after you divide by 60, you're going to get this. So you're going to get this hours. And again, we need to convert this into minutes. So what we do is this one becomes 1 hour, and we're looking at 0.6176. So I take this divided by 10,000 times 60 minutes. I'm going to get 37 point something minutes, and then I'm going to round off to 37 minutes. So again, they say state one assumption you have made. So there's a few assumptions you can make. The obvious one would be that this person runs at the same pace and same intensity throughout. So that's one. And then the other one is there's no other sauce or extra salt or whatever that she ate because all these also have calories. Okay, so that's the part B, the answer. So for the last part of the question, you can see that they give you an average working week. These are all the steps for every day on average. And then it's still not enough. So she wants to go MacRitchie and do some stuff. And there's in MacRitchie there's two routes, route 1, route 2. This is a shorter one, this is a longer one. And then her aim is to increase her average daily by 2000. So what we do is we need to figure out currently what is the average steps first. And then after that, if we add this or we add this, which one is enough to increase the average by 2000? So what we do is we need to add everything up, all this. So see, all this I'm adding. Again, there's a typo here. The last number is gone. So this total number is 44,000. Then I'm dividing by 7 because it's 7 days, right? So on average, one day in a week is 6370 steps. So we need to increase this number by 2000. Okay, so what we do is let's look at route 1. So over here, route 1, 9.5 km. So from here, I'm converting it to cm and I divide by 70. Where did 70 come from? 70 come from the very first step because one step is 70 cm. So if the whole thing is 9.5 click, divided by 70, I'm looking at 10,000 steps, 13,000 steps, sorry. So 13,000. But it is enough to increase the average by 7. Because the average step increased by 2000. Is this the average? So what we do is we take the total. So this is the total. We add this extra 13k over here, and then divide by 7 again. So this amounts to 8309. So from here you can see that 8309 minus the original 6000 plus is 19 something. This is not enough. So we do the same thing for root 2. Root 2 is 11k. So here again change to cm, divide by 70, we're looking at 15k. So we do the total plus 15k divided by 7. On average we're looking at 86k. If you take the original, the 86k minus the original 6000, we're looking at 2200 extra steps. So root 2 will be the one that allows her to increase by at least 2000. So that's the end of this question. Hope you have learned something. Thank you and bye bye.